Hello, my fellow YouTubers. This is Roy back again. Let's get right to it. This is going to be a nice test, and this proves a couple things, and we'll try them and see what it does first. All right. Number one, we got just iron bar. I'm sitting around this iron pipe. Nice core. Then we got these magnets. Now, I had to get my clicker in there, but you can't see. Some glare, right? Let me take the glare out. Glare gone. Compass is going in a full circle. Test number one. Next one, I need some light. And on this test, we're going to check to see if the top and the bottom of the pole are polarized. So we'll take the compass and we'll check. And we'll start off with the PMH here first. And remember, the pipe in the bottom is not connected, just sitting on the ground. So I am building a in-ground system that's going to be like a 2 foot, probably a 1 foot square. Okay, probably 1 foot deep. And it'll have some dielectric and capacitor plate down there. So let's go ahead and take this baby for a ride. So one thing I want to show you guys that I thought was pretty interesting that I didn't really expect, one of those unexpected things. And right here is, we're going to check the pole. It's a North Pole, South Pole, okay? North Pole. Now the PMHs are hooked up to each other by the starts are connected and the ends are connected from each coil. Okay, so they're hooked up together. So we're gonna start off right here. We got north there. Now on this side, we also have north. Over here we got south. On this side, we have south. Now, what the heck? So most coils, because these are connected, become polarized at the two ends of the coil. Not in this case. This whole coil represents one pole. Glare, I can't believe that glare. So you can see the poles are flipping on these PMHs, or actually on these coils. That pole is changes polarity and this is changes polarity. Remember, if the north is here, the north is also there. The south is here, the south is also here. All right, so let's walk it down. So now we're going to come up to the top. we got South Pole at the top of the pole. Let's work down. Glare sucks. Still south. Let's go down. Still south. Let's go down. South. Now it's turning north. All right, so now it's turning north. Now look where I'm at. I'm about 1.5 feet off the ground. Let's go up. Still north, huh? Now she's holding on a little bit. Now she's holding on a little bit. Still north. Still north. A damn glare. Let's get to the top. There we go. What's going to happen? Turning south. Sorry about the glare, guys. Turning north. So it's like really strong down here at the bottom. So the next question is, now this coils aren't fired up, so there's no power going in them. This is just straight up magnetism making magnetic poles. So we got a south pole up top, we got a north pole down bottom, okay? And in the back of the PMH, you know, it's, unless you pick a side, so there's a north on that side, only because that side would be north. That pole is south. South. See the pole here now is, see that? There's a reaction going on between this PMH iron and this pole is reacting in that circle, in the neutral part that Ed calls it. Where Ed says not much going on. Well, there's your south pole and there's your north pole. Interesting stuff, man. Very, very cool. Now wait till we stick a coil down here with an iron core. And what's going to happen there is we're going to plate the top of it. No, the plating is going to be at the bottom of this pipe. So I'm going to put a plate and tack weld an iron pipe coming up the center of this and slide a cord down there. And what we're going to do is the bottom of the core is connected to the pipe. So that means that the pipe is going to have two poles sitting right here. So whatever this pole is the opposite, right on the top flange. That's the flange I'm talking about, a flange like that. So the outside flange is going to be one pole, the center is going to be another, and that center is going to come up into the bottle. And then we'll talk about what's it going to do inside the bottle. See, one thing I guess I really want to let out there is that resistance wire is like magic. It's not so much that it resists, it's how it resists and what it does and what it allows to happen. Because if this top of the pipe has two poles, and every time this is flipping, it's flipping the poles on the top. Meanwhile, the bottom array is electrostatic collector. So we're going to put a lot of tension into the ground underneath both sides here. A lot of tension, a lot of pressure in those plates, electrostatic plates. That's going to cause the ground to react. It's going to be like a heartbeat, pretty much. Boom, 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 boom. So we're going to be allowing it to collapse and allow it to expand. Allow it to collapse and allow it to expand. Same thing up top here. So width, bam, 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 bam. There's a 4-banger. And in the middle of this 4-banger, we're gonna tack weld a pipe that comes out from that pipe here, and a pipe from there out, and we're gonna make I'm gonna call it a safety gap because it could save my life, but also a spark gap for when the system has just overpressure. It'll be able to spark gap out, and when it does that, when we see that on video, we will know the pressures that are built up that we're pressurizing down there. And then we can start running tests on where the energy's going and how we pull from it. So you guys have a great night. Leave your comments. Ed Leedskalnin goes on. Extended works of Ed Leedskalnin goes on. St. Vinny style. Peace out.